Welcome to another exciting tutorial where today I will show you a tutorial how we can use the two type of encryption in C#. The first one which we will be targeting is the DES encryption, which is basically the data encryption standard, and the second one is the most advanced type of encryption, which is basically the advanced encryption standard. Both of these encryptions are basically symmetric type of encryptions. By the way, you can go to this link. This is a really helpful link which will provide you a thorough information about the encryption standards. Since I am targeting these two of encryption services, so I will only talk about both of these two. So basically these are the symmetric encryption where encryption and decryption is done by utilizing the same key. The key represents a shared secret between the two. Basically the sender has this secret key and the receiver has this secret key to encrypt or decrypt the data. And also, this symmetric encryption is more efficient in case of the bulk data encryption. So first we will target the data encryption standard, how we can implement this in C#, and then we will see how we can implement the advanced encryption standard in C#. So I have opened Visual Studio, and I will also talk about how both of these can be attacked and which one is the most efficient. So before starting implementing the DES encryption, what I'm going to do is that you will be needing the DES crypto service provider class. Okay. Afterwards, you will be needing the crypto stream class, and then you will be needing the iCrypto transform class. These three are the major classes which we will be targeting. So I will just start here by writing some text here. Like if I'm interested here in encrypting this text, so I will just write here plain text. This text should be encrypted. We will start from here. Now, before using the DES encryption, I have to convert this plain text into in the form of a bytes, so it can be recognized by this class, and this class can properly convert this plain text into its decrypted version. So what I'm going to do is I will convert this plain text into bytes, and I will be using the encoding class. There I will use the property of ASCII to get the bytes from this plain text. Okay, I will just connect this portion, so I will see what I'm going to do. By the way, later we will convert this whole process into a form of a methods, so it will be easy for us to encrypt or decrypt the data. The next step is I will just write here the DES crypto service provider. And I will just make sure that if this class is disposable or not. So this class is basically disposable, so I will use the using block here, and I will wrap this code inside using statement. Now since I have wrapped this code inside this using block, what I'm going to do is I will show you what kind of properties I can access from this DES crypto service provider class. So as you can see, I can specify the block size, the key size, the IV, the key, the padding, and the encryptor and decryptor methods, which will return the iCrypto transform interface for me. So I will just specify the IV, the initialization vector here, and the key for this particular algorithm. So you must remember that in case of DES crypto service provider, the key size and the IV size should be the same, which should be 8 characters only. You cannot exceed from the 8 characters. Okay, so since we have stated that the key is shared between the sender and the receiver, so here we will just mimic this process. I will just write that I am interested in getting the bytes from the key, so I will say key bytes, which should be 8 characters. So here I will use this encoding class. I would like to get bytes from this key. So this is my 8 character secret key. Let me count this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, and also I will get the IV bytes, which is basically the block size also, and initialization vector 1, 2, 3, 4, 5, 6, 7, 8. So this is my basically 64-bit key, which is like 8 into 8 characters, and each character is 8 bits, so it comes out to be 64 bits. Okay, this fulfills our criteria, and this is also 64-bit IV. Okay, so we have this 64-bit key and we have this 64-bit initialization vector. Now we are ready to put this information in the DES crypto service provider class. I will specify, or I can specify this later, but I will just specify that the key size is basically 64 bits and the block size is also 64 bits. Okay, now we have got this information. The next part is what we will be needing. Now the next part is basically we will be needing the memory stream class, so we can provide the memory stream to the crypto stream class. How we are going to do this? We will just create here the crypto stream class, and as you can see, it too requires a form of a memory stream where it can store the information of the encryption process. Also, it requires the interface and the mode, like once the data is encrypted, it should be returned to that stream. So here I will first create a memory stream. Okay, now I will provide it this memory stream, and from the DES crypto service provider class I will create this encryptor where I will provide the basically these key bytes and the IV bytes. Okay, since it requires the key bytes and the IV bytes, so I have to provide these information, and the crypto stream mode, which in this case I like that the stream should be returned to this memory stream. Okay, next I will check if this crypto stream is disposable. Okay, in this case I should be using statement, so our memory resources can be freed up. Now I have got this crypto stream service, crypto stream, and now what I'm going to do is I will be needing the stream writer, so this stream can be written to some reference. So I have to make an object of this stream writer, and basically this stream will get this crypto stream. Okay, and now I can write this stream writer write anywhere. Now here I will write this stream basically this stream writer will give us the functionality of writing the stream in the memory. So in our case, since we would like to encrypt the text, the plain text, so I will just write here this stream writer will write, and then I will say okay, write this plain text in this stream for me, so it can be encrypted for me. Okay, next thing is that we will be requiring this writer to flush, so all of the extra information in the stream writer should be properly cleared. And also I would be requiring this crypto stream to flush the final block, because we won't be needing this. And the last thing is we will convert this memory stream which we have created earlier, this one, into a meaningful format, which is basically a string. So here I will just write final encryption, and I will write convert to base 64 string, and here I will provide this memory stream, and since I will start from this is 0, and the last thing is I would require this. This is giving me an error. Okay, I have to provide the buffer because it requires the bytes. Okay, now the encryption has been done. Let's display it on the screen. How does it look like? See, our text has been encrypted in the form of like these arbitrary characters. As you can see, none of these characters are readable, so text has been encrypted. Since by the definition the key size should be 64 bits, let's say if I increase this key size to 65, it won't. See, specified key size is not valid for this segment. So this is a strict rule that the key size should be 64 bits. Also the block size or the IV should be 64 bits. The next step is to decrypt this information back. So since we have covered how we can encrypt this text, I will convert this whole process into a form of a method, which will be easier for you guys to follow. So I will just create or I will say DS encryption and here I will copy all the information here and just paste it here. Since we will be requiring the text from another source, so I will just convert it into a plain text. I will remove this portion here and remove this comment here too. I will write here final encryption and say it should be empty at the start. Everything is done, and at the end I will return this final encryption. Okay, now since we have encrypted this text, we will be requiring to decrypt this text. So I will copy this, which is pasted here, and I will say this is decryption. The decryption process is simpler. I will just write here this is basically encrypted text. So in first case, since we have got the encrypted text, now we will be converting this encrypted text into the form of bytes. So I will just say convert these into a form of bytes, and I will just replace these variables. As I am using ReSharper, it has replaced all the variable refactoring for me in this code block. Now this encrypted text has been converted to the plain text bytes. Now what we will be needing, we will be just needing here a decryptor here. Obviously these are some of the steps which we have to be doing. So we will be using the memory string class, but in this case we will be converting the text from base64 string to its bytes representation, because we are going to be reading the information, so we have to be converting from base 64 string, and I will provide this encrypted text. Okay, now what we will be needing here is that we will also change this create encryptor to create decryptor, and also we will be changing this crypto stream mode write to read, and in our case here we won't be using this stream writer. Okay, we will only be using the stream reader. So and in this stream reader I will provide the crypto stream object here, and finally I will just write stream reader dot read to end, which will read the whole stream for me, and it will store it in the final decryption string object. Okay, now let's test this and see if it's working or not. I will just say encrypted text equals to and I will it will decrypt this encrypted text. I will provide this should be decrypted. Now I will run this, and as you can see our encryption worked perfectly and decryption worked perfectly. This was the encrypted string and this was the decrypted string. You can write anything, like you can write anything and it will encrypt and decrypt the data for me. As you can see here, the encryption and decryption has been done perfectly. So this was basically the data encryption standard, which is a 64-bit key. Since this is not the most secure version of encryption and it can be easily cracked, as we will discuss later here in this attack crypto system article here. So what I'm going to do is I will write the same code for the AES, the Advanced Encryption Standard, and we will see what changes the Advanced Encryption Standard brings for us. So I will discuss this in the next tutorial with the discussing this article. Also, if you want to check the information, you can go to this link here, and this is a good website which discusses these encryption in details. So please write your queries in the comments if you haven't got anything properly, and I will answer you guys in